When we're looking for key features of a quadratic function, it's important to remember to identify what form you're in. And for the sake of all the examples we're looking at here, we are in standard form. Remember that standard form is f of x equal to ax squared plus bx plus c, where a, b, and c are your coefficients. So when I look at function number 1, I can see that my a value is equal to 1, my b value is equal to -2, and c is equal to -3. To find the vertex, when you're in standard form, you're going to first need to find the axis of symmetry, which, as you remember, is the x value of the vertex. The formula for the axis of symmetry is the x equals opposite b over 2a. So in this case, since b is -2, the opposite of -2 is +2. The 2 in the denominator is part of the formula. Make sure that it follows over and is always there. And a in this case is equal to 1. So my axis of symmetry is 2 over 2 times 1 is 2, and 2 divided by 2 is +1. So the x value of the vertex is 1. We're going to substitute that value back into our function to determine the y value, to determine the output. So we're going to solve for f of 1. When the x value is 1, what is the y value? Don't forget parentheses. So 1 squared minus 2 times 1 minus 3. 1 squared is 1. -2 times 1 is -2. That's equal to 3. 1 minus 2 is -1. Minus 3 equals -4. So the y value of my vertex is -4. So here is our vertex, -1, -4. In order to find the zeros, which is another name for your x-intercepts, please remember that the y value must be equal to 0. That's why we call them zeros. It's where we cross the x-axis and the y value is equal to 0. So I'm going to rewrite my equation to be 0 equals x squared minus 2x minus 3. And since this is not in factored form, I need to factor it in order to pull out the solutions and turn them into zeros. So I need two numbers that multiply to -3 and add up to -2. So if I play around with my 1 and my 3, it's either -1 and +3 or +1 and -3. And since I want these guys to add up to -2, I'll choose those. I want a +1 and a -3. Remember, when we're solving for the zeros, when we want the x-intercepts, when we want the solutions, both of those factors get set equal to 0, and we solve. So x is equal to -1, and when I add 3 to both sides here, x is equal to +3. Those are your solutions, your zeros, -1, 3. If you're asked to write down the x-intercepts or the coordinates of the zeros, please remember to write them as ordered pairs. The -1, remember, and the 3 are my x values. The y value of the ordered pair was 0 because that's what we started with. So -1, 0, and 3, 0. And then finally, for the y-intercept, remember that the x value is equal to 0. So there's two ways to go about this. The longer way is to put a 0 in everywhere I see an x. So I'm going to solve for f of 0. Very similar to what we did over here when we solved for the vertex, just I had a different value for my x. Here, the value is always the same. When I'm looking for a y-intercept, the x value is always 0. So f of 0 equals, it was x squared minus 2x minus 3. Well, 0 squared is 0, minus 2 times 0 is 0, minus 3. 0 minus 0 is 0, minus 3 equals -3. So my y-intercept is 0, comma, -3. Remember, we substituted an x value of 0. The output is my y value, -3. The other thing you can remember is that when you're in standard form only, the y value of the y-intercept is your c value. But please remember to always write it as an ordered pair, 0, comma, c.